Hey everybody, this is Mr. James, and this video is to help you out with some of the parallelogram properties that we learned in class the other day. What you should have is the parallelogram station packet. It's got 4 pages with station 1, 2, 3, and 4. The first station is basic angles, second page is sides, third page is advanced angles, and the fourth page is diagonals. On each page, problems 1 and 2 are kind of basic problems that just use numbers. Problems 3 and 4 start to use algebra, and problems 5 and 6, sometimes there's a 5 and 6, are going to be more difficult or challenge problems. So what I'd like you to do is for each page, 1, 2, 3, and 4, I need everyone to be able to finish the first 4 problems. If you're able to finish 5 and 6, good. You should probably be able to do 2 challenge problems out of the whole packet on pages 5 and 6. If you finish more than just 2, let's say you finish 3 or 4 of the challenge problems, please make sure you hand that in so you can get some extra credit. What I'm going to do in this video is, for each page, I'm going to show you an example of how to do some of the problems. They're not the same exact problems that you'll have in your packet, but they're going to be similar. So let's get started. Okay, what I'm about to work on is from page 1 with basic angles. Again, these problems aren't in your packet, but they're going to be similar. So watch this to get an idea of how to do the problems. So, what do we know about parallelograms? Well, one of the things we know is that angles, angles that are opposite each other, like those 2 angles, are congruent. So this angle right here, 138, or G, is the same as E. So this would be 138. Angles that are next to each other, that are consecutive, like this, G, and this one, F, add up to 180. They're supplementary. So if that's 138, we can just take out our calculator and pull it up in front of us. Take our calculator, and we've got 138 minus 180. Okay, that's going to be 42. 42. Okay, and D would be 42 as well. So over here, again, if this angle is 98 degrees, then what would we do to figure out this angle? Well, we would just take our calculator and do 180 minus 98. That would be 82. 82. This angle would be 98. This would be 82. Okay, good. What about if we throw in some algebra? Okay, what about this kind of problem? Well, we look at these 2 angles, and we say, okay, how are those 2 angles related? Well, if you remember from before, they add up to 180. They're supplementary. So we can set up the equation, 61x minus 1 plus 120x equals 180 degrees. Okay? And then we can go ahead and solve that to figure out what x is. So let's see, combine like terms, 61 and 120 gives us 181x minus 1 equals 180. We can begin to add and subtract from both sides. So I'll add 1 to both sides and get 181. X equals 181. Divide both sides by 181. Okay, and I should end up with x equals 1. Okay, but I'm not quite done yet, because even though x equals 1, I haven't answered the question. Find the measure of angle K. So let's do that. If x was 1, we go back to angle K, which was 61 times, well, x is 1, minus 1. We plug that x back in to angle K. 61 times 1 is 61, minus 1 is 60. So angle K equals 60 degrees, and that's our answer. What if, on the other hand, I gave you a problem, and this is a little different, where I gave you maybe these 2 angles. Maybe this was 3x minus 5, and this was 2x plus 1. What if I gave you those 2 angles and I told you that this was a parallelogram? Okay, how would you figure out what x was? Well, you could set up an equation just like we did before, but in the last equation, we had 2 angles that added up to 180 degrees. In this case, our 2 angles do not add up to 180 degrees. In fact, they're congruent. They're equal to each other. So we'll set up an equation like this. X minus 5 equals 2x plus 1. Okay? And this problem that I just put up there, we would keep going. We'd solve just like we did before. But it's important to remember that in this case, the two angles add up to 180 degrees. And in this case, the two angles are congruent. They equal each other. That ends page 1. So go ahead and try the 6 problems on page 1. See what you can do. And pause this and come back for page 2. Page 2 is all about sides of parallelograms. Well, what do we know about the sides of parallelograms? Well, we know that the two opposite sides of a parallelogram, like FE and GD in this picture, are congruent. So if this is 18, this is also 18. Let's say I knew that side FG, let's say I knew that was maybe 20. What else could I say? Well, if this is 20, then the opposite side over here, ED, will also be 20. 20 centimeters, 20 inches, I'm not sure. But the opposite sides are congruent. So what if we see a problem like this? Find DC. Find DC, okay? Well, the first thing I need to do is set up an equation to solve for x before I can find out what DC is. So how are these two sides, CD and BE, how are those related? Well, we just said that opposite sides are congruent. So since they're congruent, their side lengths will be equal. So I can just set up an equation where they're equal. X plus 22 equals 2x plus 22. Okay? And then I can go ahead and solve. Let me get some more room. Go ahead and solve just like I would normally. I would, let's see, just subtract 22 maybe from both sides. Okay, 22's cancel out. I'm left with x equals 2x. Okay, I'll subtract an x from both sides. So I get 0 equals x, and I'm done. 0 equals x. But I'm not quite done yet because they wanted me to find DC. So I go back, here's DC. It was x plus 22, but now I can plug that 0 in. So 0 plus 22 is just 22. So DC is 22. That ends the problems on page 2, so you can pause the video here, try the 6 problems on page 2, at least get through the first 4, and try problems 5 and 6, those challenge problems. Good luck! Right, page 3 is advanced angles. Before we start talking about page 3, I want to make sure we know what a diagonal is. A diagonal is any segment that connects two of the vertices inside a polygon. So the blue line right here, that's a diagonal. This is a diagonal. That's another diagonal. So when we talk about diagonals a lot for the next 2 pages, so just to make sure you know what they are. Those are diagonals. Okay, let's look at number 9 here. We're given that this is 46 degrees, and we need to figure out what this question mark angle is. Remember that a parallelogram has 2 pairs of parallel sides. So this side and this side are parallel, and this diagonal kind of cuts through them like that. Now, if you remember from the beginning of the year, this looks kind of like 2 parallel lines with a transversal cutting through it. And actually, it is. And these 2 angles that we're dealing with, the 46 degrees and the question mark, look like alternate interior angles. And if you remember, alternate interior angles are congruent. So if this is 46 degrees, this is also 46 degrees. So the question mark is 46 degrees. Let's take a look at 10. 10 is a little trickier, and there's a few ways to do it. One way to do it is, this is 115 degrees, right? This angle right here, this whole angle, UTS, that whole angle right there, remember, is supplementary to 115. We talked about in the last section that 2 angles that are next to each other, 2 angles that are consecutive, are supplementary. They add up to 180. So I could do 180 minus 115, okay, to get 65. Okay, so this whole angle here is 65 degrees, but I don't want that whole angle. I want this smaller angle right there. Well, if I know the whole thing is 65 degrees, this smaller part right here is 31 degrees, I can do 65 minus 31 degrees to get 34 degrees. And so that question mark is 34 degrees. That's one way of doing it. Let's look at another way of doing it. Another way of doing it is instead to remember that this question mark is actually the same as this angle up here, right? We learned that in the last problem. This is also a question mark. And then I look at that shape that I have there, and I notice, hey, that there is a triangle right here. Triangle going on right there. And then I have 2 angles of the triangle, here and here, and I need to find the third. Remember that all three angles of a triangle add up to 180 degrees, so I could do 180 minus 31 minus 115, and I would get 34 degrees. So that this is 34 degrees, and this is also 34 degrees. Now there's a couple other ways to do this one, but those are the two easiest ways, most straightforward ways of doing it. Again, a little confusing, but if you go slow and think about it, it shouldn't be too bad. Let's add in some algebra. Let's look at this question here. Find the measure of DFG. Wow, okay, well there's a lot of stuff going on in this problem. The first thing to do is to figure out what x is. So I've got to somehow write an equation to figure out what x is. Well, if you're a little stuck, the best thing to do is just start trying to fill in the diagram with everything you know. Well, let's see. I know that the opposite sides, this right here, and this, the opposite angles, excuse me, of a parallelogram are congruent. So maybe I'll fill in 10x minus 5. Okay. I also know that this angle and this angle are congruent. That's 37 degrees. I also know that, let's see, this angle and this angle are be congruent. So this is 4x minus 6. Okay, and now, wait, it looks like I've got this triangle here. Okay, just like before. With the 10x minus 5, the 37 degrees, and the 4x minus 6. And I know that all the angles in that triangle are going to have to add up to 180. So I can write an equation just like this. 10x minus 5, okay, plus 37 for that angle, plus 4x minus 6 for that angle, equals 180 degrees. 180 degrees. And then I can combine like terms, I can solve, I can keep going, or on each side, I can figure out what x is, and then I can plug it back in to find DFG. But really, setting up this equation is probably the hardest part, okay? So, if you're stuck, the easiest thing to do is to start writing in angles wherever you can, using whatever you can, and going slow and thinking about what we know. The angles of a triangle out to 180 degrees. The angles in a parallelogram across from each other are both congruent. Things like that. All right, this ends page 3. Go ahead, try the 5 problems on page 3. Get at least through the first 4 and try that number 5 as the challenge. Good luck. Now we're on page 4, diagonals. Okay, so this is going to talk about the lengths of the diagonals. Now the most important thing to remember is that when we have a parallelogram, we draw them the diagonals actually bisect each other, which means that these two halves are congruent, they're the same length. These two halves are congruent, they're the same length, and this is kind of like a midpoint right in the middle. So let's try and apply that to number 6. So, first thing to do, EB equals 10.2. I'm going to label EB is 10.2. Now ask me to find EG. EG. Well, let's think. EB is 10.2, and since I know that those diagonals, they bisect each other, this is also going to be 10.2, and so the whole thing is going to be double 10.2, or 20.4. 20.4. There it is. For 7, looking at 7 now, let's see, XC is 21.4, and it asks me to find what CZ is, CZ. Well, this is even easier. We know that the diagonals bisect each other, so that both these halves here and here are congruent. So this will also be 21.4. Not too bad. 21.4. Let's try to add in some algebra. All right, this problem right here. It says FC is x plus 13. It also says that FH, this whole thing, is 3x plus 17. Okay, and I've got to somehow write an equation and solve for x, and then go back and find what FH is. Well, these two things don't equal each other. This and this, they don't equal each other. They're different. This 3x plus 17 is the whole length of the diagonal, and x plus 13 is half. Wait a second. This will also be x plus 13. Okay, and now I can write an equation saying that x plus 13, the first half, plus x plus 13, that second half, equals the whole thing, 3x plus 17. And then I could solve this, keep going, solve that, figure out what x is, plug it back in to figure out what FH is, okay, and keep going. This ends page 4. Good luck. let me know how you do.